here's one. The ether of space-time physics is the empty set of pure mathematics. The present note is basically an announcement of a theoretical and experimental resolution of one of the most basic fundamental problems of physics, namely the very existence and reality of the ether. This is not only basic philosophy of science or insightful results in theoretical physics and cosmology, but more than that, because it may lead to actually realizing the futuristic dream of free energy. Our mathematical and indirect experimental verdict is that the ether exists and it can be equated to the empty set of pure mathematics. More precisely, the ether may be understood for all mathematical and physical purposes as being identical to the empty set underlying the Penrose fractal tessellation universe, which obeys Kahn's corresponding dimensional function of his non-commutative geometry. It is then a relatively short distance to conclude from the above that cosmic dark energy is simply the energy stored in the ether empty set, so that the agreement between the theoretical calculation and the numerous accurate cosmological measurements may be taken as an indirect experimental confirmation of this spectacular model for the ether. In fact, the mere fact that Penrose fractal tessellation is a well-known and valid model for quasi-crystals, that is, a real material with five-fold symmetry, as well as for the cosmos at large, is a sufficient fact to reinvigorate an old analogy between photons and phonons. And one little more. Seen in this larger imaginative new reality, we can go on confidently repeating what we have claimed for many years, that space-time is physically real and may be regarded as a highly advanced material which can be harnessed to yield practically infinite clean, free energy via what we called a dark energy Casimir nanotech reactor. Such a reactor was thought of by many visionaries before, but was never given anything like a firm mathematical and experimental justification as we did within the E-infinity theory proposal.
Yeah, that's really say it all. You find something as simple as the ease of calculation when you use the golden mean number system. And then suddenly I take a book which is way above my mathematical knowledge, which is a book of this great mathematician, Alain Connet, non-commutative geometry. And just out of curiosity and stubbornness of an Egyptian engineer, I opened a book without the slightest hope of understanding anything in it. I don't even master the language he's using. And suddenly I find a picture, which I can understand. It's a fractal picture. He called it Penrose universe. And he said in his book, he had the privilege to be in a lecture given by Sir Roger Penrose, whom I know very well because of all his popular books and all what he done in fractal and things like that. And then suddenly I find an equation which immediately jumped into my eyes because it's full of golden mean. I thought this is crackpottery. I thought it is just for people who do numerology. So numerology is very important after all, because one of the greatest, I dare even say the greatest man in pure mathematics who work also in physics. He's a friend also of many physicists. They always talk to him. And so the golden mean he was there. And then I started compare how I write things and how he write it. I would say this is the only thing which I done better than him is the way I wrote his
Equation?
The equation for the vital dimensional function. originally, this dimension function, without having the golden mean in it explicitly as he done, because he didn't have an explicit model due to Roger Melrose. It was von Neumann in his continuous. He wrote the same equation but without the golden mean, a very abstract equation. And then I looked to a formula I used in my work, which is called the bijection formula, and found for the first time was the light that what Garnet said to me, and I didn't fully agree at that time, but I fully now agree. Writing things in a different form can sometimes means the whole world. Mm-hmm. And really the way I wrote the bijection formula, it is identical to that of the dimension function of Alain Cornet in his book.
The bijection formula.
The bijection formula. Mm-hmm. But my way is far more economical and straightforward, mm-hmm. and doesn't need many pure mathematical explanation. And from that moment on, it was clear way all the way. I realized immediately the fallacy of this numerology claims and this crackpottery with golden mean, and this is all half sort of ideas and playing around with number and all this, things which are really devised mainly to discourage you and get you out of the field. But we are not easily discouraged in any case. And it was very clear to me that this is the way to understand. And it comes from my work then and the work of Alain Cornet, the following. Let's start by topological dimension. You have a cube. The cube is three-dimensional. But what is the border of the cube? This is the surface of the cube. There are two dimensions. So the surface of a three-dimensional body, manifold, if it's differentiable, is two-dimensional. 3 minus 1 is 2. Okay. Let's look to the surface of a square. What is the border of a square? Square is two-dimensional. The border has a line. They are one dimension. 2 minus 1 is 1. So they are one dimension. Okay, let's take a line then. It's one dimension. What is the border of the line? The end point. There are points. What is the dimension of these points? 1 minus 1 equals 0. Well, that square with our normal geometry. Normal geometry is, by the way, wrong. Here, then, another question, which took imagination. Somebody, a very young man, a Russian Jew, highly talented, Pavlovich, actually, Eurizon. He asked himself the question, further still. Mm-hmm. He said, what is the border of a point? Mm. Now, for ordinary people, such a question is nonsense and crackpottery. But he asks the question. Mm-hmm. Mm-hmm. And in the school, the great school of mathematics of Moscow, from where all the greatest names of the Russian science come from in mathematics, he was there. And he said, imagine I write a general equation, not the dimension of whatever I have, minus 1. I call this dimension n, minus 1. Give me the border of whatever n is. Mm-hmm. So if if a point is zero dimension, as we just reasoned, and we agree with that. So the border of the point is 0 minus 1 is minus 1. And that is the empty set. And that is really the solution of everything. But you needed another step. You know, Ball Horizon was mad, and I was madder. You need to be more mad than mad in order to say that. And actually, it was done in a different way by the inventor of the word fractals, because fractal was always there. But he invented the word Benoit Mandelbrot. Mandelbrot said he would like to know the dimension not only of an empty set, but the degree of emptiness of an empty set. Because why stop there? You have now something called an empty set and have a dimension minus 1. So you want its border? Put another minus 1. It becomes minus 2. So that is an emptier set than minus 1. And go like that indefinitely to minus infinity. And from the bijection formula and from the work of Alain Cornet, now we can find the insubstantial nothingness about Heidegger and Sartre were taking, the real nothingness, where nothing exists, not even the question. Phi, written as 1 over phi, like you do, or you see, which is equal 1 to 1 over phi, and put as the exponent, as a power, minus infinity. It becomes phi, called the mean, the 0.6180, not the 1 plus.
Right, gotcha.
It becomes, so it's smaller than
1.
Than 1. And it is to the power, it went up. From minus infinity, it becomes plus infinity. Something smaller than 1 and to the power of infinity is absolutely disappeared now.
Right.
So you cannot ask what is the border of that. That is nothingness. That is the real nothingness. And can you imagine now the difference between the zero set, which is, I equated it, and it worked out fantastic and got the result of experiment and theory correct. The zero set is a quantum particle. Actually, it's a jump to say it's a quantum particle. The zero set is the pre-quantum particle before you can call it quantum particle. And the empty set is a quantum wave. And the still emptier than the empty set, it becomes the surface of the quantum wave, which is space-time. And when you go on and on and on and on, then you arrive to nothingness. This is really the basis of everything. And all anomalies, all paradoxes, totally disappear. The paradox was completely normal. You are mixing between zero and empty and nothingness. You see? And this, being careful of making this distinction.
Being careful to make the distinction between those three things.
And this paper is what sets our scene for everything.
So with the term ether.
Well, this is again, you see, we are imaginative lot, but we are not accurate lot. So when we don't find quickly something mathematical, as a physicist, we invent a word for it and finish. Ether, there's no ether. Relativity sends the ether away. We don't need any ether. Don't bring the ether back. The ether is back. Because we are talking all the time about space-time and all these things. Of course, these are different words for the same thing. It's tautology, they call it in philosophy. But you want the proper expression, it's empty set, and emptier still, and empty, and empty, and empty. So space-time, you can consider the quantum wave part of it, and the quantum wave is the service of the zero set, which is the quantum particle, pre-wave. And all this multi-fractal of empty set from phi, the small phi, to the power of 2, till phi to the power of infinity, where everything disappears. All this multi-fractal is what we call space-time or ether or whatever. And of course, relativity did not take the ether away at all. Again, the problem is when people talk with confidence, although really they don't know what they're talking about. And the only people who don't do this mistake are pure mathematicians, because they are not just scouts running around searching for something. They go very systematically and very slow. That's why we scientists who work in engineering and work in physics have no patience for them. It's not part of our training. But when you are a pure mathematician, although you are very slow, but whatever you gain is solid as hell. And we are asking such deep questions now. They're very deep. You know, they're related with soul. They're related to religion. They're related to what is beauty. They're related to so many things which nobody would have normally thought it's part of physics. But it is part of physics.
So in terms of language, David Bohm used to propose as a possibility that the ether was the vacuum state, but that there's a more precise way of looking at it.
Yes,
as you suggest.
yes. He is right. And that is what shows. You know, he's an inventive man. So he didn't find anything mathematically handy for him, like Heisenberg. He never heard the name matrices. But Born, his teacher, said, "Oh, what? Born, his teacher. He's the grandfather of Olivia Newton-Jones." Really, Born. Born said, "I've seen somewhere in my mathematical education, there was something called matrices or something. They used to multiply things like you do, non-commutatively." Okay. And that's it. David Bohm's imagination was without limit. But his knowledge of mathematics and pure mathematics had a very, very restrictive method. This was not part of it. They did not, for instance, attend the conference about Einstein as a physicist and philosopher, which was done by a philosopher, Schlipp. He done it, and he produced a book. And in this book, the proceeding of this old conference in honor of Einstein, made by a philosopher called Schlipp, there was a paper by Menger, by Carl Menger. And Carl Menger is the inventor of the empty set and the minus one and all that, like Horizon. There is thought who was first. Paul Horizon, I think they were independent. Most of them were very honorable Jew and scientists. I don't think they lied. So they just, a correct idea come to a lot of brain at the same time. We don't live in a vacuum.
Like Wallace and Darwin.
Yeah, exactly. And like
Newton and
Garnet, Nuttall, and myself. I must say, I wouldn't have came to all that independently without Garnet. And also to a certain extent. But we don't live in a vacuum. And sometimes we read a lot of things and forgot where we read it, and we think with old age, we think this is our thoughts. Although somebody told us maybe 10 years ago and forgot. No matter what it is, we are all part of the main. We are all part of this universe, and we're working together. Consciously or unconsciously, we are working together.
And it almost seems like when the right problems arise, the intuition takes over, and it's almost like the answers, solutions are seeded into multiple people simultaneously who come up with the solutions. And so there's not really so much a priority that someone say, I got it first, but rather, aha, eurekas are happening almost simultaneously.
Yes, yes. Sometimes, however, self-interest for funding and money and things, we're human being all.
Sure.
It's just we brainwash ourselves and start being a little bit, more I
The
instead
ego.
of
Sure.
saying we.
Sure.
But at least, I don't know anybody of us, not you, not me, and definitely not Garnet, nor Notal, have waged war against people because they use something else. But unfortunately, this is one point which make me sad. But then again, in life, there are so many pleasant things, like the friendship between us, which make you forget this thing. And the most important thing, what you mentioned yesterday, forgiveness and forgetting also. It's a blessing to forget things.
Perfect note for us to take a break. He had signaled me.
Yeah.